All right, and we're back. And it's COMP392. That's advanced graphics here at Centennial. And like I said, I was a little bit sick on Friday, so you may not hear this regular voice that I got going on. But we'll try our best today, and then hopefully by Wednesday, back to normal. Let's talk about mouse movement a little bit with our game. And for this project, I'm going to go with the project that we've been working on for the last couple of times. We're going to continue to work on one project only, so that way we can learn from how we progress, right? So I'm going to bring up Visual Studio Code here. And I'm into COMP392. We're working with a lesson that I'm going to duplicate called Lesson 8 right now. And let me just get in there. So if you notice, I have Lesson 8's right here. We're going to make one from Lesson 8 called Lesson 9, right? But all we're going to do is we're going to duplicate this lesson. I'm going to put it back up on GitHub and modify it. So let me just do that right now for you. And before you get in there, I'll show you how it's done one more time, because people, for whatever reason, still don't know how to do this properly. Again, I'm on the Mac, so I'm going to just click duplicate here. But you can certainly do the same thing on Windows by copying and pasting, and you'll get a lesson that's slightly different than, or a folder slightly different than what you have, probably with a 1 behind it or something like that. There's Lesson 9. What I'm going to do here is I'm going to pull up. I'm going to try and get rid of the. Well, be nice if I did it the right way. I'm going to get rid of the hidden Git repository here before we do this kind of stuff. So I'm going to go CD, and I'm showing you this over and over again because, you know, just that way there's no excuse that Tom never showed us how to do this enough times. Okay. So remove my install after using the Mac.git. You can also right-click on the hidden Git folder on Windows and click delete if you have access to do that. And the way you get access is to show your hidden files and folders, right? Okay, that's done. And now I'm into Lesson 9. I got to make some changes. I got to make some changes, right? So let's do that by bringing up Visual Studio Code and drag and dropping Lesson 9 in there. So before I go up online, I can I'm ready to go. Right. So again, I want to make some changes to the namings that I have in here. For example, it's not Lesson 8, it's Lesson 9. And by the way, this is a pretty common practice when you go from version 1 to version 2. You have a different branch you want to kick off. You can do it that way too. There's other ways of doing it. I like doing it this way because I kind of encapsulate my whole other project in a folder, and then I can always go back to it. It's kind of primitive in some ways, but in another way, it's nice and easy to keep track of all the changes, right? So, and it has its own little slant. So I'm not going to stop what I've done before. I'm not going to add to what I had before with Lesson 8 and leave that alone. And I can always go back and say, well, now I can compare Lesson 8 to Lesson 9 and see what I added, right? So I'm just modifying the files that show Lesson 8, moving them to Lesson 9. That's all I'm doing right now. So just changing all those little things so that I'm ready to go. And once I've got that, I'm going to create a Git repository. It's not going to take me too much longer. So I'll save everything. So File, Save All. And now once I've got all that done, I'm going to go into my repo here, or create a new repo, Git init, Git add dot, which adds everything. Could be a bit of adding. As you can see, there's tons. And then git commit -m for initial commits. There we go. That's done. Now I'm going to go up to GitHub like we normally do. And on GitHub here, I'm going to go to Centennial. And from Centennial, I'm going to create a new repository. That's just going to be labeled with today's lesson, COMP392 lesson 9. Boomity bang, I'm going to get these last two things here. And again, on the test, if we ever do a test again, you're going to have the same kind of stuff that we had last time, right? So it won't be anything that you haven't seen before when we do this again and again. Okay? Repetition and all that. Okay. There's a lot of stuff going up. I got like 15 megs, 17 megs, all kinds of stuff going up there now, right? How come so big? Why is this project so large? Anybody know? There's all kinds of stuff in here that is included that I don't need to normally include, right? Good thing is I have a gitignore file that's not including node modules. That's good. right? That's not going up. The Bower components won't be seen, but the Bower, I am including the Bower that I've installed, all this stuff, so you don't have to do it. Otherwise, typically in a regular project, if I was working with somebody else, I wouldn't include this either. I wouldn't include this scripts lib folder. I put that in here in my Gitignore file, and it would ignore that. Okay, so we're up and running with this thing now. You should be able to go and grab it. So why don't you go, for people who are watching nicely and smartly, please go up and grab this little repository that I just made. I just made a copy of lesson 8, call it lesson 9, and you're ready to go. If you haven't waited and you did it on your own, that's good too. It's good practice. All right, so last day what we did was, let's just kind of recap where we were at. So I'm gonna I'm gonna show this lesson here by clicking, kind of entering gulp, right? If everything goes well, it should compile and run my my little game that we've got going on here. And there's my little physics simulation, right? When I click on here, I can actually move my block left and right and stuff, but I got some problems. There's some issues still, like that, right? And it's pretty cool, but it's like I'm like, whoa, that's like very good. There's some adjustments we need to make, right? Because it's jumping, it's cool, right? But there's some problems. Now, we're not going to adjust the gravity and all that stuff just yet, right? Because once we start adjusting gravity on the entire world, it's going to get pretty hairy, right? So up until now, we've got regular movement going on. We've got physics working on the block. We've got physics working on the ground. We've got physics working on the falling ball kind of stuff to understand how all that works. Let's review the code from last week. And remember, next day, it's not today, but next day, we're going to do a bit of a quiz on some of the stuff we've covered, right? So please, the best way to study, of course, is to do, right? So check out the stuff that I'm going to be showing you again. If I go into my scripts core folder, and if I look at my game.ts file that I've got going on, and let me just put this up for you, things we did a little differently than last time. We're going to start off with a lot of variables, but we're getting some newer ones, right? One of the ones we've kind of put in is the clock variable. What's the clock variable for? Review. Clock. Huh? It's not just for physics. It's for what do I do with the clock? What am I using the clock for? Right? Time.delta time. It's exactly what it is. It's exactly the same stuff we get in Unity, right? So what I want to do is create that, kind of like the regular flow, almost like creating that what we get in our Unity stuff with fixed update, something that happens, on the tick of the physics engine as opposed to every frame. We don't want to wait for the machine to run every frame because it's going to be machine dependent. We want to wait for time to tell us when to do our physics simulation, so it's more natural, right? And so we need to be able to use the clock for that. Okay, notice that we did a couple things differently than we normally do, right? One, we have our geometry, but then we have a Fizzy.js material. In order for us to have any kind of physics, we need to add, the material is where we start adding this in. That's one thing we need to change. The other thing is the mesh. Now I made them just meshes. That's the superclass of Fizzy.js.box mesh and so on. But we need to make those of type Fizzy.js as well. Otherwise, again, you won't have any kind of, the physics won't be taking effect the way we want. So there's a couple of changes. Also, the scene itself, the scene of our game now is a scene, and I've changed scene up here in our alias. This is why I like aliases. Instead of it being a 3.js scene, it's a Fizzy.js scene, right? So if I ever do this again with you, and I say, okay, convert your 3.js, code, whatever, into something that works with Fizzy.js, first thing you need to do is change the scene to a Fizzy.js scene. Otherwise, again, none of this will work properly, right? How about a web worker? What's a web worker for? Because I asked you guys, this part was already there for you, but what's a web worker for? What is a web worker? Oh, God, this is going to be on your test. Think about it as a coroutine, actually. So I want you to think about it as a coroutine or a separate process that runs in the background, right? It's kind of new to HTML5. And what you can do with it is you can make it so that the physics simulation is running in another process or another thread. That's really cool. And it uses this web worker in order for us to work. I included it for you, and I don't expect you to remember how to do it because it's a little advanced, but it's just a all I've done is point everything to the right location. That's all you have to do. Okay. By the way, all the documentation is on the Physy.js website for how to set this up in the setup. Okay, but that's what you need to do. You have to set up a web worker. Okay, cool. We're using a fat arrow function here instead of an anonymous function. All I've done is replace it on the TypeScript side, right? And as we go down, just to notice what we've got our UI, but we haven't really used our UI. Our stats are still showing frames, and we haven't used our UI because we've enabled, once I click on the screen, I can't click on my UI anymore. I don't know if you check that out, but you can't do it anymore. You can click on there again. If there's a little place, if I actually created a UI, in this particular example, I could try and click on the screen somewhere, but it's not going to do anything, right? Unless I release my pointer lock, that would be a problem. Here's the thing I haven't told you, or we've talked about, but you don't have to use pointer lock for any of this stuff, right? I'm doing it because I want you to get the idea of how do I have pointer lock, get pointer lock or control of my game. Sometimes it's important for you to do that and to understand how to ask permission from the user, right? But for your game, for assignment 3, it's not required, right? So if you can't make pointer lock work, and if you want to make your game work cross-platform, it's okay. You don't have to use it, right? But the way we get pointer lock is, first of all, to describe what pointer lock is. And again, if you notice, what I had to do was I had to say, well, have pointer lock is a Boolean type variable, right? It's going to say, do I have it or not, right? That's all have pointer lock is. And what I'm doing here is I'm testing it. I'm saying, well, if pointer lock element exists in document, and document would be the document object model, right? Then if it exists in the DOM, cool. Then have pointer lock is equal to this, right? If this doesn't exist, try Mozilla pointer lock. If that doesn't exist, try WebKit pointer lock. And if that doesn't exist, well, then it's false, right? That's what's happening. You're going to get a false. So if we have pointer lock, that means if pointer lock is true, right, that it exists, that it's your browser supports pointer lock. That's what this is doing. Then I can do the rest of this stuff over here, right? If we don't need pointer lock, we don't need to do any instructions the way we've been doing it. We don't need to use this element control. We don't need to do a bunch of stuff that we've done. And part of this little exercise was to kind of enable and disable pointer lock. That's all it was. It was an ancillary technology. It's not required for us for assignment 3. Okay, so here we just describe our new clock. Right, so we're kind of instantiating it here before we get into our game object. And notice that when we have pointer lock, I want to be able to enable my controls. I don't want to enable any kind of control of my mouse or keyboard until I've got pointer lock. That's what I want to do. Okay, we set up the gravity. We did one thing else last week. We also changed the type definition library for 3JS because it was broken. And it happens sometimes with TypeScript. One day things are going to get better, and as more and more libraries come out or that are compatible with TypeScript, and maybe when we move away from TypeScript and go into ES6 or maybe ES7, who knows when that's going to happen, right? When more browsers are compatible, and good luck with that one. You know how long it took for HTML5 to be cross-browser compatible? Years, right? So it'll take that long for probably ES6 to kind of take hold, right? And when that time comes, hopefully by then, you guys will all know TypeScript. And if you know TypeScript, then you know ES6. ES6 for you will be like nothing. People who've never used ES6 before, they're going to be like, it's going to be a whole new world for them, right? But for you, you've been using it for a while. As we go through, we created a spotlight. This was there from the get-go. I kind of put this together. And I've also used this shadow map width and shadow map height of 2048 to get really sharp shadows on our objects. Again, you can control your scene, your lighting the way you like. You don't have to use my base project at all to make your project. I've got my ground geometry, and I talked about how my ground geometry last week was a box, not a plane, because planes work really weird in Physy.js, right? And it's better to make a box really, really thin. And again, I kind of created a box that was 32 by 32 by 1. We can actually make this a little thinner. We can make it half a point, if you will, and then it would be okay, because now all we're doing is we're flattening out a rectangular prism to the point where it looks like it's a plane, but actually it's just a flattened box, right? With two sides, actually, which is a little different. We've also established that we're going to add a convex mesh, and there's different kinds of meshes we can add, right, to our box as well. One thing we notice is our box geometry right now is, even though that's 32 by 32, I also have other options I can put in here. I can split my box up with different width segments and height segments, right, or depth segments. And if I was to do that, it adds complexity to my box. It makes it smoother, right? And the challenge with that is the smoother I make my box, the more vertices and polygons I'm going to eventually have on my screen, which makes it more complex. Right? So you want to try and reduce those as much as possible. So right now we don't have any divisions. We also talked about other kinds of materials that we could use instead of a convex, or so other kinds of meshes. Instead of a convex mesh, you can use a height mesh map. And a height mesh, what it does is it actually, if you were to move our player around a height mesh, and if we had more division, every division, we actually would feel all the divisions, all the little breaks, all those little, we would feel them. I would just like skip over them all. We would actually feel every single point, every break inside the box, which is kind of weird, but it could be really neat if you had a weird shape to your object. All right, so we added this thing in. We added shadows. We gave them a name. And remember, I told you how important names are now because we're using names for collisions. We can actually use names for collisions to detect which object is colliding with the other object, right? In our player geometry, and again, eventually what we're going to do, I'm going to see if I can do this for this week, is I'm going to convert my player object into a class, right? Which makes sense because then I have controls that I can add in with my player. I can use class composition to use, instead of declaring my controls here within my main program, I can use class composition to use controls only for my player class, right? So that I can enable that object as part of the player, not part of the whole global scope, right? But for now, this is okay. And all I did was for the player, we created a box mesh. That's what we did, right? And what we've done is we created a Lambert material, right? Lambert material actually for the ground as well. Lambert material, one thing it doesn't allow us to do so nicely is there's no shine. It's very matte. Lambert material is always very flat and matte. There's no specularity whatsoever. For that, we need, what kind of material we need for specularity? Huh? There's three materials we're going to be working with a lot, right? Basic material, Lambert material, and we haven't covered one. Phong material. Phong material allows you to have specularity. And it's more complex, and it's also a nice material to put in something like textures, right? Which we're going to be talking about this week more, right? So Phong material. So if we wanted to, we can make this a Phong material, but then it allows us to use things like how specular, how shiny an object is, as opposed to just how it receives shadows. Okay, so that's one thing. So we made a very simple box geometry player. We also gave the name of the object as player. That's what we did last time. And then we created a collision check. This is what this thing is here. This is our, we use an event listener. So this is our collision check, right? An event listener that was, we created an anonymous function here to say that, well, when we collide with the ground, I'm checking that the event name is equal to ground. And if we collide with the ground, then we want to kind of say, well, then I know I'm grounded, right? And if I'm colliding with my sphere, then I know I can hit my sphere, right? Well, this is the basis of how we can do things like collect points and get hurt, right? So we can kind of gather a some kind of score. This is how we did it last time. I'm reviewing this because I know some of you still don't get it, right? So I'm putting it out there because I'm gonna ask some of these questions next day when we get together. I'm gonna say, so what does this mean? What does this mean? And then you may not know. Let's talk about some other stuff. So our sphere is very similar, and notice I said, 2, and then I also, that's 2 is the radius of the sphere, and 32 by 32 is rings and kind of divisions. I've kind of split it up so it's a very smooth sphere. You can make it as basic as you like. It becomes not quite a sphere at all. And if I was to change this, like let's say for example, I made this like 5 by 5. It's kind of a weird number, and I kind of recast my. We saved everything. Let's see what it looks like now, right? Doesn't look much of a sphere. It looks like some kind of weird, polygon, right? That kind of rolls, right? So the more complex those numbers, just like we did before, the more, realistic the sphere is. That's why we put 32 by 32. That's probably the max that you want to put in there. You can make it higher. You can make it 100 by 100. But beyond 32 doesn't make any sense. Like, don't go too crazy here unless you want to make it really truly smooth. So we had our stats object, and we also did a resize function. That's one thing I put back, a resize function. Here's our pointer lock change. And this is where we actually gain control. So I said keyboard controls enables true, right? So we do this here. And what we do is we have a blocker div that basically kind of is an overlay that goes in front of the entire screen. And what I'm doing is I'm showing hiding that the instructions when you click inside the screen there, when you get pointer lock. Okay, that's really it in a nutshell for how to turn this stuff on, right? And here in our game loop, we do all of our check to see if we're moving around. And I'm using time.delta time, multiplying that by, well, we kind of had a testing mechanism of about 400 points of force, if you will, right? To kind of move our objects around different directions. Here's something that I put in the last minute. When I'm doing jumping, and you guys didn't ask about this, but I'm using a velocity of about 2,000. That's why I kind of float. Ooh. Here, I'll show you what I'm talking about. So I'm back here, and I want to jump, so I press space bar, and then you see that it's kind of a float, right? If I jump really, really high, I'm going to flip over, right? So woohoo, right? And then it's like, notice how I flip. But I'm kind of, even if I flip in the wrong direction, I kind of slam back down again, right? Oh, and I'm back down. And we talked about this, that how my box, no matter how I make it, there's still a little bit of restitution that the box has, bounce, because it's squishy, right? The box isn't super hard, and the reason why is because I don't have any subdivisions whatsoever. The box is very simple, right? The more stuff I add to the box, the harder it can become. I can also add more mass so that it doesn't float around as much. So that's kind of the way it works in this case. But so there's a case for us changing the gravity. Instead of it being -10 on the Y, I can make it -30 because that's more game ready. Because -10 is more of a physics simulation where you're falling. -30 is more realistic in terms of how we want to see the gameplay. Now, caution, when you increase the gravity, what also happens? Come on, guys. I'm going to ask this question on test. I increase the gravity, what else happens? Right? What other negative effects do I have when I increase the gravity? Well, the speed, the acceleration due to gravity is higher, so it's going to come down faster. Yes, what else? They're going to be down. My velocity values are going to be lower, which means I'm going to be pulled down on top of that ground plane a lot more. There's going to be more friction because I'm pulling everything down to that ground more because I'm increasing my gravity. My gravity scale will be out of whack, so I've got to keep that in mind. Let's check. Let me show you this for a second. Right? So we did this kind of before. So let's go up to where we see our gravity, which is way up at the top here. Here's our gravity, right? And let's change this to -30, right? And I'll save that and kind of redo everything and come back, right? Now you see that what happened. Instead of our sphere bouncing away from us, right, it landed square. And if I try and press space to jump, right, it's like I gotta, it's not really a jump anymore. I gotta like hold space down to kind of move up into the point where it goes all the way down, right? And pressing it moving forward, look how much resistance it has. Take a look. It kind of trudges along. These are kind of our bad thing. We're kind of moving it along, and it's scraping along the ground. Take a look. Scraping, right? Because there's resistance. I put resistance on the ground, right? I put, I've increased the resistance. So if you don't want it to scrape around like that, that'll stop really quick. But it'll actually bounce around. Take a look, right? So nice idea making it -30 because it falls a little better. And again, if you see the speed that it falls, just to see that, it fell like much faster, right? Boom, boom, right? And maybe -30 isn't the right number. Maybe -30 is too much, right? So let's vary that. And this is where you have to do your game testing a little bit. So let's try -20, right? And if that doesn't work, if it's still too fast or it still doesn't work properly, oh, that's a little better, but then it killed my block. My block went bye-bye, right? See that? Take a look. -20 was such that my block gets knocked off as well, right? I'm mentioning these things to you because you may be tempted to play with this number, but I'll tell you that there's other things we can do to make this more effective. Let's leave this where it was. Okay, a couple of other things that go on here. So we had another class for our controls, just to recap from last time. Again, just review, because I want you guys to know what we did from last day. Pain. Okay, let's continue. So we have a, out of our core library, we have an objects library, and in there we've had this keyboard controls class that we created, right, last day by hand. Notice that we had all these key codes right here, right? So these are our key codes. And by the way, these key codes are the same across any computer program, C, C++, you know, whether you're doing it in Python or whatever, they're the exact same ASCII key codes that we use for key control for our keyboard, right? Now there's two different events that we're tying into. One of them is the on key down event, right? Where when we press the key down, it detects how long the event is being pressed. Every time it's down, it keeps making our move forward, our move left, or whatever you're pressing, those Boolean variables true, right? When we let the key go, we have also the sister event, on key up, right? And on key up happens when you let the key go, and then it kind of levels you out. So it stops that event from firing, right? The on key up event, right? It turns it off, so it turns movement off. And that's how we did kind of, you know, moving forward and back. I want to do the same thing today, and this is the new one we're going to build, right? We have this one that I have a stub for it, and if you look under mousecontrols.ts, I built a stub, so go there for me, please. Now, there's a couple things I want to do, and we're going to have some challenges. So I'm just going to point it out to you from the very beginning, because it's going to look like it's nice and easy, right? But we're going to think this out a little bit, right? So I want to be able to move my controls from my mouse. Now, we talked about this last time. I'm going to ask this on the test as well on Wednesday. Remember what we talked about? What's pitch? We talked about pitch. What's pitch? Up and down. So along the y-axis, right? I'm kind of moving up along the y-axis, looking up along the y-axis and down. So I'm rotating where, though? I'm not rotating around the y-axis. The y-axis rotation is this way, right? So yaw, right? Yaw is along the y-axis when I move left and right along the y-axis, right? So the y-axis is a pin that goes up and down through the character, right? But this, what's it rotating on? It's got to be on the x-axis, right? So pitch happens on the x-axis. I go up, I look down. What's looking up and down? You got to think of this to yourself. The camera. Okay, I like that thinking. The camera is looking up and down. By the way, I'm telling you this in advance. If you try and parent your camera, right, or create the parent as your player, and you make your camera parent the player, it will not work. Why will it not work? If I want to look up with my camera, but my parent object is the player because I'm following the player around, can I look up with the camera? No, because my player position, rotation, and scale is governing what's going to happen with my camera, right? So then, I don't want to parent it. I don't want to have that kind of relationship with the camera. This is what's going to happen. What I want to happen is I want to be able to move my player around and have the camera follow. So we're going to create a camera follow script kind of idea, right? But we're not going to parent it or create a child relationship with the parent-child relationship with player and camera. Please don't do that. You'll have a load of problems. I'll show you what happens, right? It seems easy, the easy solution, right? But it's not really what happens. And if you actually do that even in Unity, it still doesn't work properly. If you ever try that out in Unity, right? And it'll do the exact same effect you'll have here, right? So you don't want to exactly parent-child. You want to be able to say, wherever the point is, wherever the center point or the location of my object is, my player object, I want the camera to be there or higher than that, right? But when my camera looks up, it has nothing to do with the player, right? It's nothing to do with the player. My player looking up and down, nothing to do with it. When my player turns, though, I want my camera to turn. Because if my camera was independent of my player turning, that would be weird, right? Because then my player direction, my camera direction has got to be the same, right? But my head looking up and down, that's a totally different thing, right? So there's some mechanics here. And the first part of this thing that I want to get with you guys is, let's talk about this yaw and pitch idea. Again, yaw will be handled by the y-axis. right, as we go left and right. Because Y is the pin that goes through our player up into this three-dimensional area, right? And pitch is going to happen on the x-axis, but pitch is not going to be handled by the player, because if I pitch my player, the whole player is going to jump. The whole player is going to move like this. It's going to like do backflips. All right, we don't want that to happen. Okay, let's go back. And also notice that something happened when I dropped my player in place. Some weird stuff happened, like it flipped over when it landed. I want to control that. What can I do to constrain my player so it doesn't flip over? And I got to think about ways of doing that, because if I don't constrain my player, he'll flip, he'll move, he'll do stuff that's really weird. I don't want to limit him really across the his y-axis. I want to limit that as much as possible. But if I limit him across the y-axis, that means he won't be able to jump. So I got to take off the constraint when he's jumping, but when he lands, the constraint's back. Some finicky, kind of scripting that I have to kind of put in place. All right, so here in my object, in my mouse controls object, this is the first time we've been talking a bit, but I want to talk about what I need. Let's put in some potential stuff that I want to put into my my object. One of them is I want to kind of describe a sensitivity. Right now, I'm not going to use it, but I'm going to put in a sensitivity. Whenever my mouse moves around, I might have to reduce how sensitive or how fast I spin around, right? So sensitivity, I'm going to put a number in there. I want to public a couple of other values. One of them is going to be called yaw. Again, that's going to be the way I turn left and right, right? When I look left and right, that's the yaw, right? So this is look left and right, right? And this is going to be spinning around, and this is going to be twisting around the y-axis, which is the y-axis, right? It's associated with the y-axis. If you don't do this y-axis stuff won't work properly. Okay, cool. And the other one is I want to do pitch. Pitch is not pitch like as in it's not that kind of pitch. It's pitch as in like looking up and down, right? So look up and down. Up and down. And we're going to constrain that across the x-axis. Right? That's what's happening. Okay, so those are the three public variables we need, right? One thing I want to set up from the get-go is some defaults, and I think numbers that I've played with that work nicely are this dot sensitivity. Let's leave that right now at 0.1. So it's very low, very insensitive. We're going to make it. We're going to increase that later on, but the default is going to be 0.1. This dot yaw, right, is going to be 0, and this dot pitch is also going to be 0. I want to set those up right away so we know that they start off when you make this. When you construct your mouse controls, they start off at 0. Okay, I want to be able to enable and disable my mouse controls, just like I did with my my keyboard controls. And so for this, I'm going to go in here and go public enabled, or is I don't know if it's enabled or is enabled, right? But what do we call? Let's make sure we mirror everything. So we called it enabled, right? We're going to say the same thing. Our mouse controls enabled, and we're going to make it a Boolean. And by default, did I make a default for my keyboard controls? Did I put in something in here? This dot enable is equal to false, right? So I want to be able to do the same thing, right? So mouse controls, I want to do the same thing. So before anything happens, I'm going to say this dot enabled is equal to false. So I'm going to make it so that the keyboard and the mouse controls by default disabled until you click into the screen, right? More control. All right, I want to kind of define a couple of more add event listers, right? So we're going to do this. We're going to say, remember how we did it last time with our keyboard controls, right? We had document.add event lister, and the document represents the document object model, right? The whole document. So anywhere you click on the document itself, the event listener will move, right? So let's try this out. I'm going to go back here. I'm going to say, I only need one of them this time, which is kind of weird. So it's going to be document dot add event listener. And the event listener we want to use is mouse move, which is a little different than what we've seen before. It's not mouse over or mouse out. It's mouse move. Anytime I move the mouse, I want something to trigger, right? And we're going to say this dot on mouse move. We're going to call it on mouse move. We don't have it yet, right? mouse move. And we're going to say dot bind, and we're going to bind it to this. We're going to bind them again, just like we did last time. And the reason for this is because we're binding the document model, right? So again, if I go back to what we did with keyboard controls to remind you, we use the bind keyword, right? The bind keyword, what it does is it's a method that binds our event listener to the document, right? If we don't use the bind keyword, it won't work. Okay, just FYI, it's required. False means we want to do it on the bubbling instead of the capturing phase. And I'm going to be explicit here as well with the mouse. So I'm going to say false. We don't have an on mouse move event. We're going to create one. And we're going to say, we're definitely going to have our public methods. That's what these are, right? And one of our public methods that we're going to make is, of course, on mouse move, right? So we'll say public on mouse move. We're going to pass in a type of event, right? And the type of event is going to be a mouse event. Right? And it's going to return void because it's not going to do anything other than, kind of trigger stuff to move around. All right, so that's it, really. We've got our mouse, and we've got our mouse move, and we're going to change 2 values right now, and we're going to expand this later on. One of them is ya, right? This.ya, and this is where it gets kind of funky. I want to make it so that I want to activate the X and Y. And in order for me to activate the X and Y values for my mouse, it's actually on the event variable that's incoming. This event argument houses a bunch of different things. If I type in event dot, notice all the different kinds of things I have. Capturing phase, cancel, blah, blah, blah. But if I look down to anything with mouse, like movement X and movement Y, are the ones I want to capture, movement X and movement Y. So for ya, if it's on the Y-axis, this is funny, right? What am I capturing, movement X or movement Y? It's on the Y-axis, but I'm actually capturing movement X. Why? Because my mouse is moving left and right. Left and right, but I'm spinning around the Y-axis. This is why I'm just telling you what's happening, right? I'm rotating around the Y-axis, but I'm actually moving my X left and right, right? Okay, I'm just saying this, right? So here's the other question. Should it be negative or positive? No, I'm saying, should I invert this left and right movement, or should it be positive? Be careful here, because it really depends. So let's leave it as is for now and see what we have to do. So movement X, right? And we're going to multiply it by this dot sensitivity for now. Whatever the sensitivity is, right now it's 0.1. We're going to multiply our yaw. We're going to create our yaw by taking the raw movement amount. And by the way, the movement amount that I'm going to get, which is different than the mouse X and mouse Y position, is a number between 0 and either a positive number or a negative number. Okay? I'm telling you, that's how it works with mouse movement. I'll show you in a second. In fact, if you want to show, if you ever want to see what event.movementX is, we can always you can always show that by doing a console command. We'll do that in a second. I'll leave some space. And then this dot pitch, which we're not going to use yet, we're just going to make it so it's there. Let's do the same thing. We'll say event is equal to event dot, and again, it's going to be movement Y this time, because Y, because what I'm saying is when I move my mouse up and down, right, like forward and back, that's the Y, right, on my mouse. So my mouse actually moves left and right, that's X. But if I move up and down, or forward and back, that's the Y, right? X and Y on my table, right? It's the way it has to work, right? So if I multiply this by this dot sensitivity, right, I have kind of an idea of movement. Okay, I want to be able to show, now nicely, yaw and pitch and enable, they're all public variables. So I'm sharing it all for now, right? You can always turn this down and whatever. Is there something that I could do, theoretically, to create a superclass for this? Or would you, if it was you, create a big class that does both keyboard and mouse events? Would you do both? I warn you against it. Okay, I'll tell you. And some people might be, maybe you may be tempted to do both. I would recommend to you that you leave this as 2 different input managers. All right, one input manager for keyboard, the other input manager for mouse, because that way, one won't clash with the other, right? And you can always instantiate 2 objects and turn one or the other off, right? Okay, so let's try this out. So we've got our mouse. I've saved my mouse controls. By now, it's already transpiled. So this is the transpilation version, the JavaScript. I want to go back and test it now. So remember that what I want to do is after I've done this little class, we should have some control, right, of what we're going to do. But for now, I want to do a couple things. Where would I, if I did stuff for my game.ts, I'll go back to my game.ts, we want to enable and disable our object, right? We want to declare our object as well. We want to instantiate our mouse controls. Well, if we did our keyboard controls here, might as well do our mouse controls, right? Now, I've done some of the work for you. I've created the module. I've also added it into, like I said last time, into the index.html page. So you can see that keyboard controls are scripted in, and you have to do this for every one of your custom modules, as well as your mouse controls, that's scripted in too. So if you're going to add one of your own, you'd have to do this by yourself. But I've done it for you to save time. And I've also done the same thing in our reference.ts files. I've added the keyboard and mouse controls in our reference.ts file so that the compiler knows where to find everything, right? But otherwise, it's pretty normal. It's ready to go, right? So back into our game.ts file, if I've done my keyboard controls here, one thing I didn't do is I didn't create a mouse controls variable. So let's put them together. So here's our keyboard controls. So let's say above line 65, if you downloaded my project, I'm going to put it in there. I'm going to say mouse controls is of type objects, mouse controls. Okay, so I've done that. And now what I'm going to do is down in here where I set up my keyboard, and remember, where did I instantiate my keyboard controls? It has to happen somewhere where, before my game loop is here, right? So it's got to be somewhere over here. It's got to be somewhere way up here, because once I know if I got PointerLock, right? And before I have PointerLock, I kind of instantiate my object. Doesn't mean I have any control right now. Controls are disabled, right, by default. Let's do that here. So I'll say mouse controls is equal to new objects mouse controls. Hey, and again, if you think about what we're doing here, I'm building up things for you, components. If you look at mouse controls and keyboard controls as a component, right? Then I'm building up these two components, and what I'm going to do later on when I create my own player class is I'm not going to instantiate them here. I'm going to instantiate them into my player class so that they're hidden, right, from the rest of the world. They're in the envelope of the class, so to speak, right? Okay, so now that I've got these mouse controls and keyboard controls instantiated, this is where I instantiate both controls, and I'm going to put a comment to that effect now. So instantiate, controls, or game control, we'll call them game controls, right? And then check to see if we have PointerLock. That's what we're going to do here. Check to see if we have PointerLock. If we have PointerLock, cool, then start playing the game, right? We have to do some of this stuff. And I set up some of these event listeners, right? So that way we have two event listeners, PointerLock change and PointerLock error. Let's go back to PointerLock change for a second, because this is where I do stuff, right? Here, I say keyboard controls enabled is true. Well, you know what? I might as well enable the mouse controls too, right? So I'll say mouse controls enabled. That's equal to true, right? And when I lose keyboard or pointer lock, then I want to say mouse controls dot enabled is equal to false. I want to do that there too. For now, we understand how we're turning on and turning off keyboard and mouse controls. Right? This is where I want to do it here in my pointer lock change event. That's excellent music, but that's almost like a warning for me to take a break soon, so my voice doesn't break. Okay. So I've got that going on. What I want to do to test it before I break my game, because I know it's going to break my game if I don't do this in the correct order, is down inside my game loop. This is where my game loop is right here, right? What I want to do is I got to check to see if there's anything else I need to do to change things. One thing is it says if my keyboard controls are enabled, then do this, right? you know what, I'm checking for keyboard controls, but I can check for either one, keyboard controls or mouse controls, and I think it'd be okay. I'm going to leave it as is. I don't have to check for mouse controls, but there may be in the future some other way of doing things where we say something like this: if player controls are enabled, right? It makes more sense. That's why I'm leaving it 1 instead of 2. So both have to be enabled, right? If my player controls mean both my mouse and my keyboard controls are enabled, right? Right now we're only doing 1, but because we don't really have a player class. All right, so I want to do this if it's grounded, and that's the only time I want to only do stuff when it's grounded. So in here, between these two, here's where it is grounded, finishes, right? So here's where it begins. Here's when it finishes, right? So in here is where I want to check to see if I can move things around, right? Obviously, it makes sense. So if I'm not grounded, I can't move myself. I can't look at left and right, right? Unless that's the kind of game you want to make, like where he's like in space and he can move around too, like you can twist in the air, right? My game, unless he's grounded, he can't move. He's going to only move when he's grounded, right? Okay, so in here, I want to kind of do some checks. I want to say, well, I want to kind of show what my yaw and my pitch is, right? Because it's interesting for us to know what that is. Now remember, I'm multiplying it by 0.1, right? So I can do something like this. I can say, I want to say console.log. This is a good test too. I want to say mouse controls, right? .yaw. I want to print that out, right? I want to show that mouse controls.yaw, right? And again, and I'll call this yaw. And then console.log pitch, and then we'll do plus mouse controls.pitch. It's important for us to have that kind of understanding before we kind of put this onto our player, right? Okay, let's check this out inside of our game now. I think we're ready, finally. Let's go and try this out. Okay, so it's rolling away. I get my mouse control, move things around, and let us press escape for a second and go into inspect. And let's see if we can inspect the element, see what we got going on, right? So I'm gonna move this a little bit bigger so we can see it. Go to my console, and I got yaw -1, -0.1, pitch 0. Let's try this again. We'll go back in here, see how it says pitch 0. I move my mouse to the left, I'm getting a negative value. And I move my mouse to the right, I'm getting a positive value. So negative, positive. Okay. How's that going to translate in terms of rotation? And this is where we have to think about, how am I going to rotate my mouse or my object? Can I use my player.rotation and then somehow rotate my player around? Can I do that? Well, it wouldn't work, because player rotation and player position cannot work properly with Fuzzy.js. I'll tell you right now. If you try and do that, it'll just do this. It'll kind of move and then move back, right? And also, I mean, it's not a great amount of left and right, right? I mean, it's like we're talking about very minus. It is picking it up. Here's my pitch, and here's my pitch. If I move my pitch forward, it's a minus. If I move it back, it's a plus, right? And it's a greater degree, depending on how much I move up and down. And this is, by the way, multiplied by 0.1, right? Imagine if I made my sensitivity crazy, it'd be a bigger number, right? Right and left, up and down, right? So pitch and yaw is changing, and this is a good sign that our mouse controls are enabled, right? Once we get our mouse controls, hey, that's half the battle, right? Now we can now we got to figure out how to move stuff around. And this is where I want you guys to think about it a little bit, right? I want to change my player's rotation. And I want to do it so that depending on where I rotate it, how much I rotate it, you know, and I'm rotating around the y-axis for yaw, right? So when I move left and right, I'm moving around the y-axis, right? And when I move up and down, I move across the x-axis, right? This way. We'll try that for a bit. And then we can try that and see what happens, right? So I know rotation can't work. So what other things from a physics perspective do you know that can probably, you know, work? Let's see if I can do something else, right? So let's try this stuff out. I don't need to show this anymore because I know it's working, so we can get rid of it. let's do this. I'll say, so I know I'm grounded, and I'll say player, right? Rotation. Let's try rotation and see what happens. Well, rotation, if you notice what it says when I hover over it, it says rotation is a Euler, right? It's a Euler, right? Which is, it reminds me of stuff that we you know, when we're doing any kind of, it's in degrees, right? Or in radians, actually. So if I go into radians and try and rotate something, I know that I got to do something like this. Player.rotation plus equals to, I mean, plus equals to is the wrong thing, but plus equals to, you know, mouse controls. Let's try this out. Dot, yeah, right? And it's going to say, man, can't work, right? If I hover over to find out why, it says, cannot be applied to types Euler and number, right? So Euler is a vector, number is a value, a float, just like in Unity. I've got to assign a vector3 object to this thing, because rotation has 3 values, X, Y, and Z. That's the Euler, right? Let's leave this here for a second. So what if I did something like this? Dot set, which is what we're used to doing, right? So I have now it's a X, Y, and Z. It's built in, and I take this thing and I set it. Well, if I set it, that's not going to do it because I need to add it. So I need to kind of make this, whatever I'm doing with my mouse rotation stuff, I need to make it a new vector3 object, right? So, okay, if it's a new vector3 object, right, well, I need to keep track of where it was before. So I got to have like where my previous rotation was, what it was looking at before, and what's my new rotation now, right? Or else it's not going to, it's just going to reset every time, right? Let's kind of say that we're going to call this thing like, we'll call it var player look. That's what it is. Every single frame, we're going to do this. Player look is equal to wherever the player's looking, the rotation, or if you want to call it current rotation, player current rotation. This is what we think about doing, right? Right? Is a type of vector3 object, right? And we're going to set it right away to our current player.rotation, right? This is every frame. So whatever the current rotation is. And if you notice this player current rotation, Euler is not assignable to type vector3, right? This is my player rotation, and this is a Euler, so I could do something like 3 Euler if I wanted to try and do that. So 3, I think it's Euler. I mean, I'm not even getting my code hinting right now. Here we go. Euler, like Euler, right? So I'm basically, all I'm doing here is I'm saving my player rotation, X, Y, and Z, into my current player rotation. So first thing I'm doing, and I would do that every frame, right? Okay, cool. Now that I've got that, what I want to do is I want to add, remember, does adding an angle make any sense? It doesn't make any sense. Actually, I have to multiply. That's what I have to do with angles, right? So what I got to do something is, if this is correct, is something like this. I'm going to say, you know, player, you know, try and do this. I can say, you know, is equal to whatever my player current rotation is, plus my stuff. So I can say that's my new rotation, right? My new rotation is going to be equal to my old rotation, right? Old rotation was my current rotation plus or times my new one. Okay, if that makes any sense. Let's see if that works. So how do I do that? So when I say player current rotation, right, times equal to, and this is where it's kind of weird. Once I start typing this up, can it work, first of all? Because does times equal even apply to a Euler, right? I'm trying to make it so that, you know, you're trying to figure this out. Like we're working it out. You're doing this for the first time. You're trying to use your logic. Let's try it anyway. Times my new ya, right? Which is going to be what I'm going to do. So I'm going to say a new, right, 3.Euler, and what I'm going to do is I'm going to multiply this. My x value is going to be 0. So I'm not going to rotate around the x. My y-axis is going to be mouse controls dot ya, and my z-axis is going to be 0, and it's giving me a big underscore saying meh. It says the left-hand side of an arithmetic operation must be of type any, number, or enum type. And what I'm trying to do is do something that is not defined in 3.Euler. In other words, 3JS isn't smart enough to do this operation. What could I do? I could do something like this. Equals to player control, current rotation, times, right, the product of my new Euler3 object. I could do that too, right? But then you're going to get this other issue, which is going to say left-hand side of an arithmetic operation must be of type any, a number, and the right side is of type Euler. Both of them are of type Euler. Not going to work. So I can't multiply or add vectors this way, right? And that's the problem that we're getting into. Okay, you could also calculate the new one, because we did this last time, current rotation plus equals, right? Whatever it was before, plus equals to the new one, right? We can try that out, right? And we can try either value, plus, current rotation dot y, instead of just every aspect of it. So let's just do that. So we can kill these, and just kill this little thing here too, right? And go player dot rotation, right? Dot y, because that's just a floating point number, or number is equal to mouse controls, right? Well, mouse controls dot yeah, right? So plus equals, and we're going to do the plus equals over here, like we did when we did our little GUI controls, right? Okay, cool. This should do it, right? Okay, let's see what I get. I'm showing you this, guys, so you don't have this. You don't go ahead down this road. Not because I'm showing you this because I don't know. I'm telling you that it doesn't work, but I want to show you it doesn't work, so you can believe me, right? Okay, let's try this out. Okay, I'm trying to rotate it, but it's not doing exactly what I wanted. I'm moving left and right, and it's flipping my object. Did I hit the wrong one? Didn't I hit Y? What's going on? Here's something that happened. Let's look at the control first. It's neat, but you know it's not quite doing what I'm thinking it's going to do, right? Well, let's watch this thing fall again for a second. Just be careful. So this is one thing that's happening here. Boom. He falls over, and now it's on his side. So where is his Y? It's this way. It's this way, right? So we have to fix that first, right? Okay, so this is a quick fix for this one. If you notice that when we created our player object, right up here, we created a friction for our sphere, and a friction for our player geometry, and a friction for our ground geometry at point 4. And I talked about this, how right now this is bad, right? And let's turn it off to make it 0. So frictionless is ice, right? It's actually better than ice because ice isn't frictionless. But let's just say it's like ice, right? We'll leave the our sphere geometry a little bit different. We'll make it 0 as well, so it's going to completely slide. It's not going to roll anymore, right? And let's see what happens now with our little object. Boom, it falls, and then even with that, it just kind of rolls over, right? I don't understand, right? I made it so like before it didn't do it. So that was part of it, right? I mean, shouldn't have, look, it's getting all over the place. That's the only difference, right? So that really didn't do it because that was our problem last time when we tried this out. Restitution was 0. This is our resistance, and it didn't really do anything. So let's put that back. Okay, how else can I do it? I don't want my player to flip along any axis, right? So when he lands, he's going to have a fixed rotation across all axes, right? How do I do that? How do I set his rotation so when he lands, he's got the exact same thing? Anybody? The what? Rotation is all 0? I could do that. I could say like the rotation of X, Y, and Z, every frame is 0. X and Z is 0, right? So I can't look up anymore because I don't care for him to look up, right? If I do my X and Z as 0, let's see if that works. I'll say player rotation is Y is, you know, when I enable him, this is when he's enabled. But I want to make it so that when my player rotation starts off every frame, whether he's enabled or not, before even it's enabled, I want to have my player start off that he's not going to move. So before his update, whether he's enabled or not, I'm going to say player rotation, right? And it's going to be dot on the x-axis, right? And the y-axis are both 0. Here, dot rotation fixed. And on the z, right? X and z are both 0. So I don't want them ever to rotate. Let's see if that helps. Well, it was good. We fixed one problem, but we killed something else, right? That's good. I'm going to move my sphere out of here because my sphere hits and it's messing us up for now, right? So I'm going to move my sphere so it bounces ahead of it, right? So let's just make it so that the sphere, instead of toppling on top of our player, he's landing at 60-10, and notice I'm doing the player at 30-10, right? Let's move the sphere a little closer in, so it's going to be at 5, right? Just from a positioning perspective. And let's see if that happens now. What happens with my cat? My player lands, my sphere lands in front of it, right? Okay, cool. Let's move my thing around. Well, I'm trying to, but look what's happening. As I move my guy, it's like resisting. Look, it's going back to kind of moving, but really not. And it's trying to adjust back to where it was before, right? Look, it's not moving like I want. I mean, I'm not getting a smooth movement. I'm moving my mouse, but even if I move my mouse a lot, it kind of snaps back. Why is that happening? No. If I can't move the other way at all. If I was to try and move yaw or whatever, or pitch, it's not a chance. I've set those things to 0 every frame, right? So that's fixed. Those are constraints that I put in right now, right? But this, I've allowed it, but it just keeps snapping back anyway. How come? No matter what I do, it just doesn't matter what I do, no matter how sensitive I am, whether I'm, it doesn't really do what I want it to do. It moves a little bit, but not quite the right thing I want, right? Why? Because rotation and position can never be set in a PhysiJS and with PhysiJS. We have to use something else. We have to set angular velocity, right? That's what we have to do, right? Okay. And in order for me to set angular velocity, I need to use a new vector3 object to do that. So let's try that out. So I'm going to unlock this, go back, go over here to this, and we'll take a break after this, right? Because my voice is killing. I'm going to go back into my game loop, which is down over here. And we've done this. That's cool, right? But this is wrong. I want to do something like this instead. I want to say player.set angular velocity, which is this one. Because remember, we're talking about physics. So we have to use physics instead of that fixed stuff, right? Is a new vector3 object. And in this object, we're going to set 0 for our x. We're going to set mouse controls yaw for my y, and 0 for my z. Okay. Now this again is not going to provide the right motion because you're going to see that things are messed. Let's check this out anyway. All right. Let's go back. We'll refresh everything so you can see it. So I move left, I actually turn right. How come? And I move right, I actually turn left. Now, this is good. See how it's actually moving? I've got motion now that I want. This is the motion that I want. This is the smoothness that I want in my motion, right? But I'm moving the wrong way. Left, right. To fix this, I'm going to reverse the yaw, the negative in front of my event, like I talked about, inside my mouse controls, because I don't want to do it here. That doesn't make any sense, right? So go back to my mouse control class, right? And in my mouse control class, I want to change this yaw to a negative event event movement, right? And the reason for that is because, like I talked about, what we translate from our actual physical mouse movement to what's happening here is what's going on. The other thing is, in the future, you have to also, for our game, my game, when I play my first-person perspective games, I like my Y inverted, right? Some people like, their Y regular, right, where they kind of move forward, and then they look down when they move forward. And when they look, they kind of, this is me. So when I kind of look up when I pull back, and I kind of push forward and I look down, right? Because it's like kind of relative to the neck. I like that when I play. Some people don't play like that. When they move forward, right, as an example, they look up. because it's an upward motion. And when they pull back, oh, sorry, yes. And then when they pull back, you look down, right? Which to me is not as natural when I play my first-person perspective. Now, for the majority of people, it's the other way around. It's like they're opposite me, right? I'm the rare duck that likes to, you know, pull back and look up, right? That's, what's that? Even if I'm playing those, I like it, right? Yeah, you need it. I need inverter for everything. I need inverter when I'm flying a plane and like a, you know, some kind of plane simulator, everything else. It needs to be inverted for me. Otherwise, it doesn't feel natural, the controls. So that's a matter of choice. Okay, let's take a look at this now. So I've got my mouse move. Here it is. And let's see what the effect this is going to have when I go back to this, right? And let's refresh this thing and see what happens. So I've kind of handled this thing already, right? Well, uh-oh. What's going on? Huh? Wait, I'm supposed to, it was working before, I just reversed it. It's made it negative, right? What happened, right? Let's take a look. All I did was this, was minus my event movement. I just take, you know, reversed this thing. I turned it from a positive to a negative, right? Well, it doesn't matter, right? If that's true, if I do this, right? If I leave it here and go back to my game.ts, right? And I change this to negative mouse controls, yeah, right? That's what you're saying, right? And I go back and try this again. That's okay, right? And that's better. If I go left, I move left. If I go right, well, wait a minute. Oh, there it is. I move left, right. How come it's sliding around so much weird? Like right, left. When I get to a point that it keeps going, it turns the other way. Look, if I keep moving my mouse to the right, it turns the other way. Watch. How come that's happening? Why is that going on? So I go to the right, and then it turns to the left. And the other way, it turns the other way. And it keeps flipping over and over again. What's going on? It's in radians, right? Huh? Yeah, no matter how I move it. If I move this way or that way, right? So I'm moving all to the right, or to the left. So here I'm moving to the left now. If I move, unless I move to the right angle, right? Things get reversed to the point where if I'm moving around the circle, right? What's positive and what's negative is going to be different. That's going to be a problem. Okay. So let's leave it here for a second. Let's take a short break. I got to take a break with my voice. And when we come back, we'll fix it.